All right, so let's finish up with other measures of returns, and particularly two that are very important for Exam FM. So the things I discussed before, I think, are on Exam FM, if I'm not mistaken, but they're just very, particularly the explanations I gave for these, modified internal rate of return, profitability index, etc. They're very practical business, explanations of why they're useful. And it's stuff you'll see, particularly if you don't end up being an actuary. You'll probably wind up doing some kind of business, finance job. So you'll see these concepts somewhere down the road, even if you don't see it in a finance or an accounting course. I'm sure you will see it in that context, but in case you don't, you will see them later on. So anyway, so let's talk about first the dollar weighted rate of return. And it's an IRR with respect to simple interest. And that's really all there is to a dollar weighted rate of return. And practically, why would we be interested in something like that? Well, remember, way back at the beginning of the course, we mentioned that for very small periods of time, it's easier, it's more simple to use simple interest. I mean, in this day and age with electronic trading, I mean, you have trades going off every millionth of a millisecond probably. So to do all these, to do all these interest calculations using compound interest is probably very computational, much easier to use simple interest for these tiny little periods of time. Okay. In particular, it's sometimes used when you have just periods of time less than 1 year. Okay. So, right. So the way you're going to do this, these problems, is you're going to take the future value equals 0 to figure out this internal rate of return with respect to simple interest. Now, you're going to use the following kind of rules to do these problems. There's a formula in the book. If you so desire to look at it, it is on page 304. It is on page 304. I'm sorry, it's not on page 304. It is on page 292. It's also on page 304, but it's on page 292. There's a lot to it. It's a mouthful. I don't think it's useful. That's just my opinion. Maybe you do. All right, so you're going to treat the initial deposit as an expense. That makes a lot of sense. To get the ball rolling, we have to initially deposit something. Excuse me. Okay, we're going to treat all deposits as expenses. That makes sense. To keep the fund going, we have to, we make a deposit. That's something we have to pay. Withdrawals are considered as revenue. When we withdraw money, we're basically taking the money out. We're getting money. And we can do whatever we want with it. Smart, we'll invest it. But withdrawals give us money. And the final fund amount is revenue, because that's at the end. We make we made an initial expense. We make other expenses, deposits. We get revenue, withdrawals. And at the end, we have a certain amount of money in the account that we can take out. That's So in that sense, we think of the final fund amount is revenue. And particularly germane to the homework is that you don't care what the fund looks like in between, deposits and withdrawals. It's just irrelevant, okay? And that makes sense. I mean, let's say I have an account, and with all the volatility going on, I'm kind of paranoid at the stock market, so I want to check my account every 5 minutes, okay? That has no relevance to its yield. Me checking it doesn't change anything. Okay? In quantum physics, yes. So when you actually observe the position of a particle that changes the physics of the problem. This is not quantum physics. This is, I don't want to say it's not real life. I mean, quantum physics is real life. But you know, so just remember that you knowing what the fund is at a certain time is irrelevant to any of these calculations. Okay, so let's do a problem here. The fund begins 2015 balance of $1 million. You deposit 200,000 at the end of February and August. Pays out 500,000 at the end of October, and the balance remaining in the fund, 2016, is 1,100,000. So here, this is different. Here, it's not just, we're interested in what the fund is at for shits and giggles. Here, it's more, we start off with $1 million. That's our initial deposit. We end with 1,100,000. 1,100,000. That's our end amount. So, as I said, our initial deposit we treat as an expense. Our ending amount we treat as revenue. So it's definitely different than just in the middle of all this knowing what the benefit, knowing what the fund is. So if the problem said at the end of January there was $1,000,050,000, that would be irrelevant to any of our calculations. It's nice to know that it made 50,000, I guess, in 1 month, but it's irrelevant. Okay, sorry about that. So let's do this problem here. Okay, so we're going to just write a table. We could do a timeline, but let's just write a table, same thing, of the cash flow, basically associated to this problem. So you start off with $1 million. That's our starting balance. Okay, so we start off, begin the year, which is, you think, the end of December. So you go end of December, January, end of January, end of February. That's 2 months. So we have, So when t equals 2, in 2 months, we have our 200,000 deposit. So we treat that as an expense. Okay. And then at the end of August, so end of February, March, April, May, June, July, August, so 2 plus 6 is 8. So at t equals 8 months, we have the other expense of 200,000, that other deposit we're making. Then 2 months later, there was a benefit at the end of October, August, September, October, for 500,000, and then October, November, December. Well, at the end of December, that's it's obviously t equals 12. That was silly. We have 1,100,000. So we have those two revenue coming in. Okay. So we take, as I mentioned, we're taking the future value of this cash stream. You can theoretically do the present value, but that's really weird when it comes to simple interest, so I wouldn't even try it. Right, so this minus $1 million at the end of a year accrues 1 year of interest. And remember, simple interest is 1 plus IT, or 1 plus TI, where T is your fraction of a year. So it's minus $1 million accrues 1 year of interest. The minus 200,000 accrues 10 months of interest, so it's 10 over 12. Minus 200,000 here goes from 8 to 12. That's 4 months, 4i over 12. 500,000 earns 2 months of interest, and the 1,100,000 earns no interest. Okay. So just like with internal rate of return, you set future value equals 0. Even normally for compound interest, setting future value to be 0 is probably easier than present value equals 0 for your internal rate of return. Here it's much simpler. Okay, so all this equals 0. And yeah, it's admittedly a pain in the ass to do the algebra here, but it's not that bad. So you first divide everything by 100,000 and distribute the 10, distribute the 2, the 5, and the 11. Oh, sorry, there's nothing to distribute with this 11 here when you divide by 100,000. I'm just bringing the 11 to the right-hand side, so it's minus 11. Anyway, you do this simplification. You can check, you'll get 17.39%. And this is actually an example, page 293 in the book. Yeah, so, right. So this is, yeah, this example is done on page 291, actually. So, all right. So, yeah, so let's talk about the time-weighted rate of return. What is that? Time-weighted rate of return is a product of growth factors between periods where you have some revenue, some expense. Okay, every time you have a cash in or cash out, you look at how the fund grew or shrank in between those periods, and you multiply all those growth factors and then subtract 1. Okay. So in that sense, it makes a lot of sense. I mean, that's basically, that's basically how you find a general growth factor in general. So this is kind of giving you just the entire growth rate for the whole time period. Okay. So there's, well, one thing is that, you're going to ignore the lengths of time periods when you do these growth factors. That's irrelevant, which kind of makes sense. I mean, if you want essentially the overall growth factor of the entire fund's period or entire project's period. Okay, and the key to doing these problems is that the formula for the growth factor during a period is the amount at the end of the period before any deposit or withdrawal, divided by the amount at the beginning of the period after there's a deposit or withdrawal. And it only makes sense to do it this way. If you, let's say, you had like $1 in your account at the beginning of a period, no deposit or withdrawal at the beginning, and then at the end you deposit $100. Your $1 did not magically grow to $100. You don't really know what it grew to unless you figured out how much you had before that $100 deposit. So that would tell you $1 grew to something, and then you deposited 100. If you deposit 100, it would grow possibly to more than 100. 100 plus whatever the dollar grew to. Okay. Now, at the same time, if you have a fund starting off with $1 million, and then you immediately withdrew 500,000, and then let's say there's no withdrawals or deposit at the end, but it still accrues to 600,000. It doesn't make sense to think that your fund sucks because it went from $1 million to 600,000. No, your fund's actually pretty good because you withdrew 500,000, you're left with 500,000. And so let's say in the 1-year period, for example, if it grew to 600,000, essentially 500,000 grew to 600,000, which gives you a 20% increase, a 20% rate of return for that period, which is pretty damn good. Okay. So, right, so what we're doing is we're saying, okay, so we have, we make, at the beginning of a period, maybe we make a deposit or withdrawal. Okay. At the end of a period, we make a deposit or withdrawal. Let's ignore all that. Let's just say after the beginning deposit, we have money. It accrues to something. let's do that to figure out the growth factor. We're ignoring the deposit after that. We're ignoring the deposit or withdrawal after that. We're ignoring the deposit or withdrawal before that. Okay, so there's some deposit or withdrawal possibly. Then you have money. It just sits in the account unfettered, uninterrupted. It grows or declines, and we're trying to measure that, ignoring the fact that there might be a deposit or withdrawal at the end. Okay, so let's do, yeah, so basically exactly what I said. The amount at the beginning of a period after the deposit or withdrawal grew unfettered, uninterrupted to the amount at the end of the period before deposit or withdrawal. In this time period, there are no deposits or withdrawals. We're trying to break up everything into periods of, between here and here. There's possibly a deposit here, withdrawal, possibly a deposit withdrawal here, deposit withdrawal here. In between, there is no deposits or withdrawals. Okay, let me shut up and do an example here. So a funds reporting for 2015 is listed below, and this is taken from a book. Homework is similar. Find the time-weighted rate of return for 2015. Okay, so we're going to do this exactly the way I said we're going to do it. Okay, so right, so let's look at the first period, and that's going to be between January 1st and March 1st. Okay, and that's because we want to find the first time there is a withdrawal or a deposit. Okay, the first time there is a withdrawal or deposit is a deposit of $200,000 on February 28th. Okay. Okay. So, and the fund starts off at January 1st. Okay. If there's nothing here about a deposit or withdrawal after January 1st, we're just going to assume that there was nothing immediately after this fund date. Okay, so how do we do this? Well, so let's just use the formula. Remember, the formula is we want the amount at the end of a period before a deposit or withdrawal. Okay, so on March 1st, there's the amount $1,240,000, but that's immediately after we made a $200,000 deposit. So before that $200,000 deposit, we had $1,040,000. Take $1,240,000, subtract $200,000. Okay. So we divide it by the amount at the beginning of the period after deposit or withdrawal. Well, in this example, there is no deposit or withdrawal immediately after January 1st. So we just divide by a million, we get 1.04. Okay. So next, you can see is an August 31st deposits into the account. And we just do the same thing. And these problems are this simple. Okay. So let's look at, so we're going to go from the next periods of, between a withdrawal or deposit. That is essentially March to September. Okay, so September 1st, there's $1,600,000, but that is right after this $200,000 deposit. So we have to subtract to get the amount in the fund at the end of this period, right before the deposit. So it's $1,600,000 minus $200,000. Okay. And again, there's nothing here about a withdrawal deposit immediately after March 1st. So we just divide by 1,240,000 to get 1.129. Right? In homework, there will be often a deposit or withdrawal immediately after the starting period. But here there isn't. But you're still going to follow the formula basically. You're still going to adjust for it, right? In the same way we're adjusting here. Okay, so next is October, well, basically November 1st, September 1st, November 1st, because there is a benefit paid out on October 31st. Right? So November 1st, there's 1,080,000, but that's right after this benefit paid of 500,000. So this is after we withdrew 500,000. We had 1,080,000 after we withdrew 500,000. So right before this withdrawal, we had, well, add 500,000 to it, 1,580,000. Okay. The 160, 1,600,000, there was nothing deposit or withdrew from it right after September 1st, so we leave that alone. And last but not least, we do the same thing for November 1st to January 1st. And then we just multiply these growth factors to get 0.1809. Okay. And that is what the book gets. And again, there's a formula on page 294. I don't think it's useful, the formula. Yeah. So yeah, I mean, so yeah, if you're in the solutions section, so actually I will do an example in the final video. I might do a yield curve video. I haven't decided yet. There's not going to be any homework on it, but just because yield curves are so useful in practical finance, economics, you want to maybe do a video on it. But I will do examples from 522S and 524S, examples similar to that. And there we will see where at the beginning of periods, there will be withdrawals or deposits. Okay, and that'll be tomorrow. Definitely this is enough for one day. So, all right, yeah, I'll see everyone later. Stay safe, stay healthy, and so long. Take care.